All right, let's jump right into this explainer. We're unpacking how to truly unlock AI's potential in your daily coding workflow. Look, if you've been using tools like GitHub Copilot, ChatGPT, or Gemini, you already know they can write code at absolute lightning speed. But if you're feeling like the code they generate is sometimes confusing, insecure, or just flat out broken, yeah, you're definitely not alone. Today, we're going to look at the exact strategies professional developers use to turn AI from a messy guessing machine into a hyper-efficient coding partner.
Section 1. The AI Productivity Boom.
To really get why this matters, we have to look at the stakes. A recent McKinsey report estimates that generative AI could add up to $7.9 trillion, yes, trillion with a T, dollars in annual economic value. That is a staggering number. To put that into perspective, they highlight that this technology is poised to transform knowledge work forever, potentially automating work activities that currently eat up 60 to 70% of employees' time. We're talking about a massive, structural shift that will fundamentally change the anatomy of work, especially for higher-wage knowledge workers like us, software developers.
And as you'll see here, the McKinsey data shows generative AI adding between 15 to 40% more incremental value right on top of traditional AI and analytics. It basically proves this is a massive leap in technical automation. But, and this is a big but, as the research points out, to actually capture this value and see that sweet annual productivity boost, we have to fundamentally change how we work.
Which brings us to Section 2, the vibe coding trap, when AI runs wild.
So this quote from a fantastic Reddit thread perfectly captures how developers are literally burning money and breaking apps right now. The user was talking about a friend who tried to build a full app using AI completely from scratch with no coding background. The setup? It was a disaster. A single component with over 1,000 lines of code and at least 50 files running simultaneously. The result was that the tools just stopped working. As the user noted with a lot of perfectly justified exasperation, people just let AI run wild, building full projects, assuming the model will somehow read everything and keep it all perfectly consistent. No structure, no plan, just vibes.
Here's the harsh reality. AI models aren't infinite magic machines. They have what we call context limits. Think of an AI like a computer's RAM with limited space. Once its context runs out, which happens incredibly fast when you feed it giant files, it just starts forgetting things. When you ask it to modify a massive codebase, it ends up guessing, and honestly, it guesses really badly. On top of that, if you're using an API, you are literally burning cache every single time the AI has to reread those massive 1,000-line files.
Now, check out the difference here between the bad habit of demanding an entire app at once and the smart habit of keeping tasks strictly modular. If you just casually prompt, build a complete e-commerce website, you're going to get confusing, hard-to-maintain code. The solution, which is heavily discussed by experienced devs, is to modularize early. Keep each file under 350 lines, period. Split your logic, give clear step-by-step prompts, and you instantly eliminate the guesswork and drastically reduce those crazy hallucinations.
Moving on to Section 3, Hidden Security Risks, Dangerous Guesses.
Listen, if you blindly trust AI output without any structure, you're practically inviting severe vulnerabilities straight into your production environment. AI models generate code based on vast data sets of patterns, sure, but they do not inherently understand your specific security requirements or your company's policies. As highlighted in recent security analyses of AI-generated C# code, AI will almost always take the path of least resistance. It might generate database queries that are wide open to SQL injection or fail to properly encode user input. Hello, cross-site scripting. It might even hardcode sensitive secrets directly in your source files instead of using secure vaults like AWS Secrets Manager or Azure Key Vault. It's a nightmare waiting to happen.
So how do we fix this? Let's look at Section 4, the Modular AI Framework. Be the architect.
The bottom line is we can't just be typists anymore, we have to step up and be architects. This 6-step framework ensures you treat the AI exactly like a junior developer, guiding it through isolated, manageable tasks instead of just asking for everything at once. First, you ask the AI to act as a software architect and map out the design. Next, you focus it entirely on generating the API endpoints, like your REST routes for user login or cart management. Step 3, you design the database schema, completely separately. Only then, in Step 4, do you actually ask for the code, and you do it one single feature at a time. After that, you prompt it for testing. We're talking unit and integration tests to catch those sneaky edge cases. And finally, documentation. By breaking the project down like this, the AI maintains a tight, focused context window, giving you actual, production-ready results.
Next up is Section 5,
securing your prompts. Guide the AI.
When you finally reach that coding step, you've got to realize the quality and security of the generated code depend entirely on how you construct your prompts. You simply cannot rely on AI to just assume you want secure code. Look at the stark difference in these prompts. A weak prompt, like write a C# method to upload a file, might give you functional code, but it's going to lack authorization controls and input validation. A secure prompt, on the other hand, says write a secure C# method, validate file types and size, implement error handling, use parameterized queries. See the difference? By explicitly demanding security validations in your prompt, you instantly upgrade the AI's output from our risky first draft to something that actually resembles solid production-ready architecture.
Never forget that you are the one in charge. Always treat AI code as draft code. A core best practice here is to validate all inputs, because you can literally never assume the AI included enough validation to protect against injection attacks. You also need to enforce human peer reviews. A pair of real human eyes remains one of the absolute most effective security controls for catching weird logic issues that automated tools might just breeze right past. And finally, you must automate security testing, things like static and dynamic application scanning directly into your CI/CD pipelines. The AI accelerates the typing, but the responsibility for security, that remains entirely on your shoulders.
And finally, Section 6, work smarter, not harder.
So, unlocking that massive trillion-dollar productivity promise we talked about, it requires working methodically. It requires actual structure. Breaking your project down into concise, highly secure prompts is the ultimate secret to actually doubling your coding speed. When you guide the AI, when you force it to explain what it's doing, instead of just letting it loop on itself and hallucinate, you get vastly better results. You avoid that whole vibe coding trap of giant unbreakable files we saw earlier, and instead you create a workflow that is genuinely scalable and, most importantly, secure. I'll leave you with this question to challenge how you approach your codebase tomorrow. Are you managing your AI like an infinite magic machine or like a focused, modular developer? The absolute best developers out there don't just use AI, they know how to use it effectively. Try applying this modular framework to your next project, keep those files small, and watch your productivity absolutely soar. Thanks for joining me for this explainer, and I'll catch you in the